Hello everyone. All right, let's talk a little bit about security in JavaScript. First of all, hi from my side again. I'm Ruben. I'm a Node.js TC member and TC39 invited expert, and I work at Datadog as a staff engineer. And recently, supply chain attacks have become a major problem. So I also started to worry about that. And I want to start this talk by a quick question into the audience. Like, has any one of you directly or indirectly been impacted by it, by looking into supply chain attacks so far, taking measures into protection or something like that? Just raise your hand very briefly. So a few hands. All right. Well, I like that because that seems like you are all pretty chilled still, and I want to be there again as well. You know, we don't have to worry about it too much. We can go to our couch and relax as this cat, and that's good. But actually in the year 2025, supply chain attacks have been a major, major concern. We have had so many attacks in a way that we have never seen before. And I work on JavaScript for quite a while. I have definitely not had anything similar before. And there were, for example, some hackers that were inspired by Dune, the movie. And like to quote some of that, maybe they have thought about that. Well, let me just change one thing, sorry. Your time has come. A storm is coming. Our storm. And when it arrives, it will shake the universe. That's what they thought, and well, yeah, it did pretty badly actually. So Shai-Hulud is the sandworm, and that is the name of one of the worst supply chain attacks we have seen this year. It is a name because it is also self-replicating. And I like to have a look at this attack or the attacks that have happened recently. Well, we had one that was attacking ESLint. Now, I believe pretty much ESLint is used by everyone, right? You can pretty much not come around it anymore these days. We have had attacks on GitHub Actions where our secrets were tried to be stolen. There were other attacks where Chalk or Debug would have been attacked. Now, these are very, very common modules, and they are downloaded billions of times per week. With billions of times downloaded, it means a huge amount of devices is going to be impacted by these, and some of them were less bad. For example, with Chalk and Debug, they were only trying to get crypto mining. Okay, you know, like they were using the resources bad enough, but at least they weren't stealing any credentials. They weren't making anything other bad on these machines besides using these resources. The next one, Shai-Hulud, definitely did that. That self-replicating worm was indeed attacking it in a way that it was compromising the machine, was stealing the credentials of it, and when you were able to like publish a new version for any module on that machine with those credentials, it would automatically recreate a new package for these and then propagate it. So it was really hard to get control over this attack because of that reason. There is also another very professional attack, which is the Indonesian foods supply chain attack. Why is it called that way? Well, I'm not certain about the name anymore, but it is actually a long planned attack. It is there for more than 2 years ongoing. And people were creating packages over and over and over again in the ecosystem, just lingering there for an attack that would come later. Now, I use this term supply chain attack so many times now, but I didn't even explain what it is about. And I like the explanation of Cloudflare. So let's just cite them into about it. Attackers exploiting third-party dependencies in order to infiltrate a target system or network. All right, so by manipulating something that we are using, they are able to take over our machines, our code that we are maintaining, right? And as we know, node modules, they tend to grow. Not a little bit, they tend to really grow into a huge mess. And this has a lot of downsides. One of them is obviously also, it's a big security concern. By having so many external dependencies, we're making it very easy for an attacker to take over our machines, to take over our applications. Because we don't have only the attack vectors of our own application. Now, each individual dependency is able to be attacked as well, and that again is a problem for us potentially. So we now have to exponentially, pretty much for like all these different dependencies, also secure us. And if we think about security, security is a relative term. We will never achieve 100% security. That does not exist. What we can do is to make it as difficult as possible for us in a reasonable amount of effort that others will not be able to attack our machines, that they will not be able to take over these machines. And it is a little bit of a race. You know, sometimes we are up front and they are not able to attack us, and then they're becoming more creative with their attack vectors and their new security measures against that, and it's a little bit back and forth. That's how it has been for a long time, and I believe that is also how it's going to be for a long time. Let's concentrate on the mitigations today that we know and we have. Well, first of all, let's have reproducible builds. We want to be able to install our application on our test machine and know that exactly 100% of each file that we are installing on that test machine is also going to be installed on each individual host that we are going to deploy it to later on. Is that the case for most applications we are building? Absolutely not. Mostly, it depends on what operating system is it running on. What node version is it maybe using if you're using Node? What dependency manager are you using? In what version? What Docker containers are you using? In what version? What dependency ranges do you use, etc.? This can all, like we have Zember drift, we have so many different things that can lead to non-reproducible build. I actually only know one system that does that really well, the Nix system. So one step that we can use is log files. Log files are very, very important. Just brief hands up again, please. Who's using log files for their applications? That's good, that's good. I like it. Everyone should use them. And who of you is maintaining libraries? Much fewer people. Of those who maintain libraries, are you using log files there? No. Some are. That's interesting because normally you should not use log files in the libraries, but you should use a log file for the applications that you're building in the end. That's where you want to be sure that this is your reproducible part, because when you build a library and you have an external dependency there, you potentially also want to be able to pull in security fixes on that side automatically, and now the application maintainer has the responsibility to verify that this is indeed the correct one. They have the responsibility for that. It's not the library's maintainer normally in this case. So log files guarantee us that everything we install from Node, for example, will be there. This is just an example log file for Yarn. Of course, like npm, pnpm, they all have log files. Every package manager will use log files. Very important. And you can go a step further. You can also specify what node version are you expected to run this application upon. You can actually specify a concrete version. You can also specify the concrete package manager that you're caring about. That way we have one more step for securing something as a reproducible build. And you can also do that with the operating system that this application is expected to run upon. Now, not everything is only about these dependencies, because our applications are also running in a CI environment where we run our tests, where we potentially build things. And we normally use something like GitHub, and there we use GitHub Actions, for example. GitHub Actions, we normally want to get an update for things, right? So in this case, we will also have an open range, like here, Actions checkout version 4, because everything in version 4 we will work with well, right? That's okay. Yes, we do want to get these updates. The problem is that we did not verify if an update is actually attacked in itself. So if we automatically pull in that update, it is in itself potentially a problem. And they are able to access the secrets of the CI. And the CI will probably be the best to steal secrets from. And nowadays, we normally hide them from our developers as much as we can. And most developers do not have direct access to credentials as much, luckily. But our CI systems still do, because we have automated our deployments, etc., in a way that the credentials have to be somewhere. And therefore, we want to make sure that whoever has access to these credentials will not be compromised. So we have to pin these versions as well. And we can do this with a specific hash, and please also always use the full hash. Why? Because if you use a short hash, which exists in Git, it's totally fine for local working, like working with something, so you don't have to type a long string, but a hash will become attackable through hash collision if you use a shorter hash. It's a smaller attack vector that is left, but it still exists overall. Instead of having that open range, how do we update it? By automating it. We want to use something like the PandaBot, for example, to automatically open a PR that will then tell us, hey, this is the new version. Do you want to include this in your application, yes or no? And then it can be manually reviewed, and we can handle it properly from there. Coming back to our node modules, and this huge bunch of external dependencies that we are installing. Why do we actually do that again? Like, I'm really wondering about this, because we have so many features that are built in that we don't need to put in this huge list of external dependencies. I would say any application of a decent size should normally not have more than 30 direct external dependencies. When I say direct one, I don't include any peer dependencies, because peer dependencies, again, have their, like it's a tree structure that we build up. So if we have a lot, let's go through the list and reconsider if we really need it or not. Very, very frequently, we do not. There are a lot of things that are built in by now in the language, or if you're using Node, for example, as a built-in functionality. Now, our LLMs, or when we Google something for how do I work with something, there's a blog post about how to do something. The blog post was 7 years old, 10 years old, and it is still recommending a library, because at that point of time, the functionality did not exist in the language, because at that point of time, it did not exist as a built-in functionality in Node.js. Well, we have progressed. We now do have new features, and we should rely on them. We should use them. And that's obviously also applying for dev dependencies, just the same. We don't only focus on the regular dependencies. I would have a similar count here. I gave an example list here for lots of modules that are very, very frequently downloaded that we all do not need. These can all be replaced by built-in functionalities. Is array, it's probably more used like for browsers in this case, that would be my expectation normally, to have a fallback pretty much for very old JavaScript versions that I cannot think about anymore pretty much, because all our engines that for any browser in the world will support something like array is array. Why do we need that? Then node fetch. Well, Node.js of all supported node versions has fetch as a built-in functionality. You know, if we only have supported versions that get security fixes with these features, why do we have an external dependency there in the first place? Probably the native functionality is actually faster, has more features, or is more secure, or less buggy. That's often the case. So we get a lot of benefits by not using these libraries, in fact. More security features. So something that nature does is, for example, and it cools down, right? In springtime, sometimes it's like still getting a little bit cold, and like the blossoms that have already formed are frozen. It's okay, you know, it takes a couple more days until they're able to bloom. Let's do the same for our dependencies. When we automate our updates, let's not pull them in directly. Let's wait a little bit. Give them some time to have other people look at these dependencies and to make sure that they are secure. This will not work for all attacks, as I said, because like the Indonesian food attack was there for a long time and was not noticed before. But these dependencies were also not used a lot. And that's the reason why it wasn't detected earlier. And as such, we can use a cooldown time. That's how it's called. And Dependabot has a functionality for that built in. I don't know about Renovate. If it is not there yet, I would kindly ask the room for implementing. Because open source is always open for everyone. And it can be changed as such. And I believe that is a very important, good security feature. And of course, there are also other automation tools. I believe every automation tool should have something like that, or you have to build something like that on your own, that you just wait until that PR would be pulled in. And when we install things, ideally, we should do it with an offline cache. We have something where we have no access to internet, because that way we also prevent another attack vector, like post-install scripts, pre-install scripts, install scripts that could be executed. Yes, you can deactivate them, and yes, please do so. It's just another measurement that it is not even possible to reach the internet for whatever reason. And that is something, again, for reproducible builds, very helpful. We guarantee that it will work the same. If you're a maintainer or you're working on code, always use two-factor authentication. No SMS. SMS itself is easily to be read. It's not a secure protocol, so therefore that should not be used. And what else is there? Like when we have containers, right? We work with Docker containers, and when you pull in something, don't pull in node in a specific version. Pull in node with a specific hash. We can also pin the same thing just there as we did with our GitHub actions. It works identically. So, and of course, that's not only about the node container. You can do that with any container. And yes, our dependency automation also works for Docker containers. You can also do that, and we'll update these as well for you in an automated fashion, because that is not a work that is a human being able to do all the time. In our installations, please use something like npm CI, or when you use Yarn, it's called frozen log file, because that way our log files are taken into account fully, and the peer dependencies are installed just as we have them pinned down in our log file. That's very important in this case. And as I said before, the post-install scripts, etc., these should absolutely be prohibited. I believe they were a mistake in the first place to be included like that because of security concerns. When you look at a dependency, check for the repository's health. Is it actively maintained? By whom is it maintained? Do you trust that author? is it an authority that you would want to be able to control parts of your application? It's an important question to ask. With a lot of dependencies, I don't feel comfortable. So I would try to find something else that I would be able to rely upon instead. We can use, in addition, static code analysis, where you look, for example, for Unicode characters that make code look as if it would be a regular code, but in fact, it's something very different, because Unicode characters can be very tricky. They can, in fact, hide other code, because you can go back and forth, and depending on how it's rendered, it will look as you see one code, but in the end, something else is executed. We can check for minified code. No one should automatically pull in minified code by default. That's the tricky part. So it's a red flag. We can check against this. We can use other additional checks that help us. For example, is there any secret asked for in that module? Is there any obfuscation going on in that code? All that are red flags to protect against, and we can automate it in a CI check. What else can we do? Well, when we add dependencies or want to change a dependency, use a couple of steps. First of all, I'm looking for the dependency. I request it to be added to the module or to my application. Someone else has to review it, and they have to be proper about it. They have to really do all these steps that I have also spoken about earlier, about the maintenance, about the repository's health, etc. And then they have to approve that adding this is indeed secure. Maybe also the licenses is another important aspect for companies. Do you accept this? Is it a license that is something that you can handle, or is it in like a copy and left module, for example? Now mirror that ideally in a in a own package manager. It's not the own package manager. I lost the right word. About a package registry. That's what I was looking for, and that you can set up. And when you set this up, you can now pull your dependencies from that mirror, from that package registry, instead of the original registry. That way you have another additional layer of security in between. And as soon as we have done all of that, we can use it. Who's using TypeScript, by the way? Great, right? It's good for finding a lot of bugs. So I wanted to use TypeScript, and I installed npm install TypeScript.js. It's good, right? Any issue with it? It's a wrong package. Oh, I must have mistaken it. Huh, okay. So this is called type squatting, where people create new packages, and yes, this has been an actual package that was created as an attack vector for people who have accidentally installed something without looking up what they are in fact installing. This is happening on a regular basis, that people are creating modules that others will hopefully have a small typo, or they don't look up what it is about a very frequently used module, so that it will be installed, and then they are able to steal the credentials, have access to that machine, have an executable there. So we have to be aware of these, and that's again very important why we need that former step about that manual review. You know, that people are really looking closely at what do you actually want to add to your repository as an external dependency. Let's summarize all of that. So we want to absolutely have reproducible builds. Those are very, very crucial. And we want to have as much automated as we can, where we use log files and use pinned hashes. The concrete hashes are good when you automate things. Use a cooldown time for these automations. when you maintain anything, when you have access to any repository, always use two-factor authentication for everything. Also for publishing something. Ideally, the publishing is something that you cannot do directly, and it's completely automated as well with a CI job, something like that. And only that will be able to access these necessary credentials. Of course, we want to make sure that our CI credentials are not accidentally accessed or propagated in the wrong way, which has also happened. So we want to also pin those versions and yeah, use tokens. That's something very important. Like instead of like a password, use a one-time token how to access something. Less dependencies means way more secure. Please go through your list of dependencies. And when you do so, and you find something is not yet there that you would expect to be a built-in, well, we are living in an open source world. We can change this. And if you cannot change it on your own, you can at least open an issue on, for example, node.js to ask for that feature to being added if you believe it makes sense to be in core. What is meant to be in core is something that is very, very frequently used. Something like that is normally going to be added at some point. And be aware of type squatting. All right. So always have that mindset. Assume a dependency is an attack vector. That the dependency is indeed hostile. As soon as you handle your dependencies like that, your application will become much more secure. So, thank you very much. That's the talk. One more thing, if you're interested in that, I found it funny, like Cybersecurity and Infrastructure Security Agency published a nice doc about supply chain attacks as well, in a more generic fashion, but I thought it was a good read. So if you're interested in that, arigato gozaimasu.